Very good morning, all my dear students. Welcome back again to your Unacademy NEET English channel. I hope everyone is doing great. Have a good time. Kids, first of all, everyone do let me know, can you hear me? Can you see me? And I have something in my hand. So today we are going to start with the most fabulous, awesome, most important topic of isomerism that holds a hell lot of weightage. That is conformational isomerism. What you can see over here, this is being ethane. Ethane. Can you see everyone? Do let me know. Just a second. As I have told you, it holds a hell lot of weightage. This is ethane. These two potatoes are being carbon, and these three sticks, you can see these three sticks, they plumb are hydrogen, and this is bond. Carbon-carbon bond, you can see carbon-carbon bond and carbon hydrogen. In ethane, there are three bonds. These three bonds with hydrogen and three bonds with hydrogen. These are spoons. Simply, you can consider at the tip, they are being hydrogen, right? Everyone, can you see? If you see this ethane sideways, this is the structure given by Sawhorse, scientist Sawhorse. I will show you Sawhorse. Let me write down Sawhorse. First of all, everyone do let me know, can you hear me? Can you see me? Everyone do let me know, can you hear me? Can you see me? Sawhorse side view. This is scientist. He has seen compound sideways. Sawhorse has seen this structure sideways. So this is Sawhorse structure sideways. First of all, everyone do let me know, can you hear me? Can you see me? I can see Rishi is there. Oh my god, one plum has gone. Just a second. We can eat this. Okay, wait. Hey, plum, please stay. Now, I want to see green signal from the chat section if I'm properly audible and visible to all of you. See, creativity. I've tried a lot just to show you each and everything. Now see, kids, if you see the front view. Now, if you see the front view, this plum is visible. This hydrogen is visible, but at the back, these hydrogens are not visible. Or if you rotate it, you see, now on doing the rotation, now the back carbon, this is your front carbon, this potato is being your front carbon, and this one is your back carbon. See, Sawhorse, this Sawhorse structure, side view, this is back carbon, and this potato is being front carbon. But Newman has seen from the front view is known as Newman's projection formula, because the compound is being same. Its compound is being same, but just it is the view that one scientist is saying this compound from the front. You see, suppose right now you are Newman. So let me write down another scientist name. One scientist was Sawhorse. Another scientist name is Newman's projection formula. Newman's projection. So Newman has seen the compound from the front. This is the front view. So kids, now you can see very clearly. Is it visible to all of you? Not just to let me know. Yes. Now see kids, in ethane, carbon, there is single bond. And due to this single bond, free rotation is possible. You see, this carbon, this potato is there and it can move. See, let me show you. It is freely able to move. You can see it can freely move. You can see. Let me show you. This back carbon is remaining like this. Now see, it is automatically rotating. That means its rotation is not completely free. Vidhajanani, Ritvika, Rishi Sonak, everyone can hear me. So this rotation is not completely free. It requires some amount of energy, that is thermal, or afterwards I will eat this plum. This, for its rotation, some amount of energy is required. This rotation is not completely free. See, this is rotating. Automatically it is rotating. But it required some amount of energy, and that energy is available in the form of thermal or kinetic energy, and that is at room. And what is the amount of that energy? If you see in your NCERT, that can vary from 1 to 20 kilojoule per mole. So this rotation is not exactly free. You can see this rotation is not exactly free. For its rotation, some amount of energy is required, and that is easily available at room temperature in the form of thermal or kinetic energy. Can you see it now? So this rotation is not completely free. What I was telling you, rotation is not completely free. Rotation requires energy that is 1 to 20 kilojoule per mole, and that is available at room temperature in the form of thermal or kinetic energy. Now see kids, everyone see to it. If I say this is hydrogen, and this hydrogen, you can see just at the back, that in between these two hydrogen, this hydrogen and the back carbon hydrogen, there will be repulsion of atoms. This atom will show repulsion with this atom, right? This is known as van der Waals repulsion. And this is a bond in between carbon and hydrogen. There must be two electrons, sharing of two electrons and sharing of two electrons. There will be repulsion in between these two electrons. That is known as torsional strain. What are these two electrons? Bonded electron. So repulsion in between bonded electron is known as torsion repulsion, and the repulsion between two atoms is known as van der Waals strain. So there are two types of strain. What are they? Atom-atom repulsion will be known as van der Waals strain. Bonded electron repulsion will be known as torsional strain. Everyone say yes. You are getting Arthi, Priyanka, everyone. Do let me know. Saswat is there. Oh my God. Rishi Sonik is there. Wow, that's really fantastic. What I've told you. What are the two types of repulsions, kids? Do let me know what are the two types of repulsions. Repulsion in between two atoms. Repulsion in between two atoms is known as, do let me know if you are able to understand, van der Waals strain. And repulsion in between bonded electron is known as torsional strain. Now, if I say this is the hydrogen and this is the hydrogen, they are just colliding together. If you see the front carbon, if you see this front carbon, you won't be able to see the back carbon. Just do let me know. Are you able to see the back carbon? If I show you the front carbon, back carbon is not visible. So whenever I'm going to draw Newman's projection, I will say this is the dot. The front carbon I will draw with the dot, and the back carbon I will draw with the circle, right? Is it clear? The front carbon I will draw with the dot, and the back carbon I will draw with the circle, and the front hydrogen is just eclipsing with the back hydrogen. This is known as eclipsed configuration. Now, if I keep the back carbon same and the front is rotating, you can see right now, you can see this is one hydrogen, this is one hydrogen, this is one hydrogen. This is the front carbons, 3 hydrogens, and the back carbon hydrogen is just exactly lying in between these two, and this is known as fully staggered form. This is going to be the most stable configuration. Why? Because these hydrogens are far away from each other. You can see if I place this hydrogen over here, what is the angle in between these two? If I place this hydrogen over here, just let me bring it, just a second. If I say this hydrogen, if I bring over here, so what angle can you say in between this green marker and this plum? What is this angle? Just wait. It's rotating itself. See, it's rotating. Baba, just wait. So, what angle is there? This angle. Just do let me know, everyone, in the chat section. Assalamu alaikum, shalom, Suhail Rasid. This angle is how much? This angle is 60 degrees, 60 degree angle. Can you see? So when I rotate from 0, because in between this and this is 0 angle. This is known as dihedral angle. Dihedral angle is 0, then this is fully eclipsed. And if I rotate, you see this hydrogen I have brought over here. Now if I rotate from 0 to 60 degree, this is going to give you the most stable configuration. Now people will ask, only we can rotate by 60 degree? Can't we rotate by 1 degree, 2 degree, 3 degree, 1.5, 2.5? You can rotate by any angle. So ethane is going to give you infinite conformers. Ethane will have infinite conformers. Kids, now after this, let me go to the board. I hope that everyone is able to understand, and you can see it is rotating by itself. Can you see, kids? There is free rotation, and this rotation is possible at room temperature. You can see it's rotating by itself. See, oh my God, see. Okay, so I hope this is clear to each and everyone. Each and everyone is able to understand. Now, after the three-dimensional structure, let me come back to this. See, so first of all, let me tell you, this is your HSP Baba Magical Chemistry Guru. I have been teaching for the last 23 plus years. Produced number of ranks, that is top 10 ranks, first rank, you know, yes, second rank, third rank, fourth rank, you'll know each and every name. Now, if you're new to this channel, those who are new, this is the first day. You have to subscribe this channel if you're liking my teaching. And my dear students, all regular students, yes, smash the like buttons, hit the like buttons, everyone. It's a humble request. This is your HSP Baba. I want to see likes should get increased. Now, everyone, this I was telling you, he has seen the side view and he has seen the front view. Let me tell you, this is your ethane. Everyone see to it. Ethane. When we were in class 9th, we were writing ethane like this. Afterwards, in class 10th, we have seen ethane like this. C2H6. Then we saw ethane like this. CH3. CH3. Then sp3 hybridized. sp3 hybridized. Now, there are two scientists. First scientist name as, I've told you, yes, who is being the first scientist? I was telling you, Sawhorse. This is the line, slanting line, Sawhorse view. Sawhorse, looking like horse. Oh my God, horse. It's a name of scientist. Now, what Sawhorse did, he said, just draw Y. Just draw Y. Just draw Y. 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 Can you see this Y, and this Y? Regular Y. And keep here hydrogens. Attach over here hydrogens. One hydrogen, second hydrogen, third hydrogen, fourth hydrogen, fifth hydrogen, sixth hydrogen. Now you see, this is being first carbon, this is being second carbon. This is the side view. This is the side view and side view of the same compound. Now, let me call this to be the front carbon. If I say this is being your front carbon and this is your back carbon. Now, where Newman is going to see? Newman will put his eyes over here. He is going to see from here. Newman has kept his eyes over here and he started seeing from here. So he called it front carbon, he called it back carbon. So Newman is going to draw front carbon with the dot and back carbon with the circle. So let's see, this is front carbon. This is front carbon according to Newman. Let me write down Newman's projection formula. Newman's projection. Now, what Newman said, this is my front carbon with small dot, and he has drawn back carbon with big circle, according to him. This is his, yes, this white is being front carbon and that circle is being back carbon. Now front carbon, 3 hydrogens. Let me draw 3 hydrogens on front carbon. Y, this is being Y. Let me draw with another pen. This is being front carbon. You can see this is being front carbon. Have you seen? On front carbon, these are being 3 hydrogens. 1, 2, 3. And on the back carbon, you can see just behind the hydrogen, there is hydrogen. You won't be able to see those hydrogens. So let me make it tilted one so that you can see. Let me make tilted one. It's over here. Can you see? It's over here. Can you see? It's over here. Can you see, everyone? They are just behind this white hydrogen, but I have to draw it like this so that you can see. You must have played hide and seek. When we were playing hide and seek and somebody was hidden just behind the tree, we were doing like this. Hey, where are you, Rabu? What are you doing? So that was our criteria. Now see, everyone is enjoying it. Now this is eclipsed form. This is the way Sawhorse has seen the structure. This is the way Newman has seen the structure. And this is being fully eclipsed form. Let me tell you, this is fully eclipsed form. Fully eclipsed. Now kids, let me tell you, in fully eclipsed form, this is being least stable. Least stable. Why it is being least stable? You can see I've drawn a little bit over there. This angle is 0 degree. This is just, I have to show you these green hydrogens. Otherwise, in the fully eclipsed, green hydrogens are not supposed to be visible. No one can see the green hydrogens. So this repulsion, kids, let me tell you this repulsion. Let me make it on the another page so that you can easily understand it. Let me make it on another page. See kids, if I say this is your front carbon, this is your front carbon. Let me tell you, this is being front carbon. Front carbon. And let me draw, this circle is being back carbon. Back carbon, okay? Front carbon, back carbon. So on front carbon, if I say these are 3 hydrogens attached, these are being 3 hydrogens attached. 1, these are being 3 hydrogens attached. 1, 2, and 3. Okay, these are three hydrogens which are attached on front carbon. You can see very clearly this is the bigger structure. Now you can easily understand it, and this is being carbon. And if I say this is your back carbon, this one is your back carbon, this one is your back carbon. Okay, this is your back carbon, and to this carbon also hydrogens are attached. See, like this. They are not visible, but I'm making them to be possible so that you can see. Otherwise, you will start saying, sir, where the hydrogens has gone. Now see, these are the hydrogens just lying at the back of these hydrogens. So this is your fully eclipsed form. I see. This is your fully eclipsed form. Now in fully eclipsed form, fully eclipsed. This is your fully eclipsed form. Most unstable, maximum unstable, maximum unstable. So what are the two reasons for its instability? See, these two hydrogen atoms are just nearest to each other, and two hydrogen atoms are nearest to each other. That means what? This is indicating van der Waals strain is maximum. Van der Waals strain is maximum. So what is being van der Waals strains? Van der Waals strain arises due to the atom's repulsion. Van der Waals strain is due to atom's repulsion. And these are bonded electrons. See kids, these are bonded electrons. This hydrogen atom's bonded electrons and this hydrogen atom's bonded electrons. You know that electrons, they carry negative charge. So there is repulsion due to electrons, bonded electrons repulsion. Bonded electronic repulsion is known as torsional strain. Torsional strain. This is also known as dihedral strain. Dihedral strain. Kids, this is also known as dihedral strain, and that is being maximum. So I will say van der Waals strain is maximum. Torsional strain is maximum because this dihedral angle is 0. This angle is being 0. So this angle in between bonded electrons is known as torsional angle. What I'm saying, kids? Torsional angle. Torsional angle. Or dihedral angle. Dihedral angle, that is being 0. So always remember that ethane's this fully eclipsed form is being highly unstable. Kids, everyone is able to understand or not? Do let me know. Priyanka, Rishi Sonak, kids, everyone do let me know. Aspiring medico, that everyone is able to understand. Now let me tell you the two forms of this. If I say, first let me draw the projection given by Sawhorse. This, let me draw regular Y. You just see they are just colliding. If I write down here the hydrogen, just behind this hydrogen is here, this hydrogen is here, this hydrogen is here. This is your fully eclipsed form. Right? Now it has rotated and it has formed a structure like this. Now just try to see. This is Y, regular Y. This is your regular Y. And this one is your inverted Y. You can see this is your inverted Y. So this is your fully staggered form. If I write down here hydrogen, 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 and these hydrogens, just see, these hydrogens are just lying in between. So they are far away from each other. When they are far away, this is known as staggered form. Staggered form. Staggered form. Kids? So which is going to be the most stable? These two are conformers. We will say these are extreme form of conformer. This is being least stable form. Least stable. And that is going to be our most stable form. Most stable form. Most stable. Kids, just to let me know that everyone is able to understand or not. At least show me some energy, some fire in the chat section, so that I can understand that my efforts are working. You are able to understand, kids. Increase the energy level of a teacher. Now see, kids. This is your fully eclipsed. That is your staggered. I would like to say that here the van der Waals strain is maximum. Here the torsional strain is being maximum, and these two things are making it to be least stable. Least stable. And for this form, I would like to say here van der Waals strain is being minimum, torsional strain is being minimum. So this is being most stable form. Most stable form. Now kids, this is least stable, that is most stable. That means equilibrium will go toward that side and less toward this side. Now kids, are these only the two forms? Question arises. No, there are an infinite conformers. Rest of all in between this. Rest all forms. Rest all forms in between are known as, yes kids, are known as what? Are known as gauche or skew. Gauche or skew. Rest of all other forms, wow, that's really awesome. Rest of all other forms are known as gauche or skew. So who is being most stable? Staggered is being most stable, eclipsed is being least stable, and gauche is lying in between these. Now, if I say arrange in the stability form, so do let me know, help me, that ethane forms infinite conformers. Ethane forms infinite conformers. Forms infinite conformers. Infinite conformers. So which is being the most stable? Staggered is being most stable. This is the question of your exam. After that, there's gauche. We can also say gauche or skew, and least stable is being eclipsed. So this is the stability order. Now kids, in your NCERT, one very awesome thing is given. Very good, Priyanka. That's your really good efforts. Arthi, really good efforts. Everyone do let me know that in between this most stable form, and this is being least stable form. Could you please let me know what should be the energy difference? The energy difference NCERT is writing energy difference is 12.5 kilojoule per mole. 12.5 kilojoule per mole. That is being, this is being most this is being most stable form, and that is being least stable form. So examiner can ask this question. This question can be asked in your exam, because this is given in your NCERT. NCERT lines are really very important. This is being NCERT data, and NCERT data is very important. Now, kids, question arises. See the questions based on this. Let me give you number of questions. Question number 1, see to it. Question number 1. Methane will have how many conformers? How many conformers? Conformers. What should be answer, kids? Methane will have how many conformers? I'm waiting for your answer. Everyone do let me know. Methane will be having how many conformers? What's your answer? Bidhajanani, Arthi, Inyas, Priyanka, Ravina. Wow. Kids, do let me know. Ethane will be having how many conformers? Let me give you options. Let me give you options. Option number A, 0. Option number B, 3. Option number C, 2. Option number D, infinite. Infinite. Now kids, do let me know what's your answer. Number of students, number of times they must have studied. What I would like to see, what's your answer, kids? Wow, you are really awesome, kids. Answer is absolutely correct, 0. Because in methane, there is no carbon-carbon bond. There is no carbon-carbon bond. No carbon-carbon bond. There is no carbon-carbon bond. Fantastic. So you got success in the first question. Let me give you the second question. Everyone, hey, do let me know, are you ready for the question and answers? Because these are the questions directly examiner is going to ask, kids. Directly examiner is going to ask. Question number 2. Question number 2. Question number 2 is, how many compounds will show conformational isomerism? Will show conformational isomerism. Now compounds are, let me give you the compounds. This is compound CH4. This is compound H2O. This is compound C2H5OH. This is compound H2O2. This is compound C2H6. This is compound C3H8. This is compound. Okay, these many compounds, and let me give you the options. Let me make the options. 1, 2, 3, 4, 5, 6. So option A, 6. Option B, 5. Option C, 4. Option D, 3. So what's the correct answer? For which options you are going to mark? It's definitely, oh, good morning, Buddha Shurya. Sir, we want IUPAC nomenclature. Definitely, I will give you each and everything. Somadipik, Vomik. Kids, do reply answer smartly and speedily. Ravina is saying D. Shiva Kumar is saying D. Welcome, welcome, welcome. So most of the students are going for, I can see majority of students are going for D, and kids, you are going to get fail. See kids, you are going to get fail because the answer is, correct answer is, let me tell you, this will not show, this will not show, this will show, this will show, this will show, and this will also show conformational isomerism. So D is not the answer. Answer is being C. The fourth is being the correct answer. Now kids, how many of you want to understand why these four compounds are going to show this conformational isomerism? Kids, now you must be shocked why this H2O2 is going to show conformational isomerism. So what is the criteria? You must have studied that only in carbon-carbon there is free rotation. Kids, do let me know. Write down me, and thumbs up that if you want to understand why and what is the criteria for a compound to show tautomerism. This thing you're not going to get in your NCERT. This is the missing part of NCERT. This is the missing part of NCERT, kids. Missing part. This is not given in NCERT. So this is the drawback of NCERT. I would like to say missing part of NCERT. But number of times questions has been asked, missing part of NCERT. See kids, that's why kids are getting failed, because NCERT, in NCERT this has not been given, but number of times NCERT based questions are there. Now see, criteria to show conformational isomerism. Criteria to show conformational isomerism. Kids, the only criteria to show conformational isomerism is the compound must contain at least three regular sigma bonds. Three regular sigma bonds. What do you mean by these three regular sigma bonds, kids? What do you mean by these three regular sigma bonds? This is really very important thing, that compound should contain three regular, at least three regular sigma bonds. Just try to understand. Everyone just try to understand. If I make methane CH4, in your childhood you must have played one game. In your childhood you must have played one game. Just draw this structure, and the pen should not get repeated, and you can't lift your pen. Have you played this game? The pen should not overwrite, and you can't lift your pen and draw this structure. You must have played such type of game. Now see, the same game we have to play over here. You count number of sigma bond, you can't repeat, and you can't lift your pen. Maximum sigma bonds, how many you can count? 1, 2. Maximum sigma bonds, only 2. Maximum only 2. So this compound is not going to show conformational isomerism. Now see H2O. If I give you compound H2O, only 2 sigma bonds are there, so you can't. Now H2O2. If I say H2O2, do let me know how many sigma bonds, how many maximum sigma bonds? 1, 2, 3. These are 3 regular sigma bonds. That's why H2O2 hydrogen peroxide will show you conformational isomerism. And inorganic chemistry, in your inorganic chemistry you must have studied, kids, that H2O2 has number of structures, open book like structure, this structure, that structure, and that is the conformational isomerism of this compound. Kids, are you able to understand or not? Do let me know. Now all the compounds Means all alkanes will show conformational isomerism except methane. So I can say very clearly all alkanes will show conformational isomerism except ethane. Ethane, it's not ethane, methane. All alkanes will show conformational isomerism except methane. Now kids, let me give you one more question. I'm going to give you one more question. That's really awesome question. Question is, which compound will have maximum rotation energy barrier? Maximum rotation energy barrier. One is being ethane, A is being ethene, B is being your ethane. These are the two options, ethene and ethane. Kids, do let me know what's your answer. Ethene and ethane, which will have maximum rotation barrier. I would like to see your answer, kids. Hurry up. Everyone, do let me know. I'm waiting for your answer. These questions definitely are going to get in your examination, NEET 2024. These are really very, very important for NEET 2024. Fantastic, kids. You are rocking. You're rocking. So this is your answer. Why is this the answer? Because double bond due to pi bond, there is restricted rotation. There is restricted rotation. Now kids, two more questions I am going to give you, right? Two more questions I am going to give you. Just try to understand. Question number 1. By what angle rotation must be carried out in ethane to get most stable conformer from least stable. Kids, do let me know what's your answer. I'm waiting for your answer. By what angle rotation must be carried out in ethane to get most stable conformer from least stable? So options: option A 0 degree, option B 3 degree, option C 45 degree, option D 60 degree. What's your answer? Which answer you are going to mark for, kids? I'm waiting for your answer, kids. Do let me know. Oh, Vidhajanini 60, 180, 300. Claps. Everyone claps for Vidhajanini. Oh my God, really awesome. That's really fantastic. Vidhajanini has given something more than required, 60, 180 degree, 300 degree. So here the answer is going to be 60 degree. Otherwise it can be 180 degree, as well as Vidhajanini has written 300 degree. All of them, they are being correct. That's really fantastic. Claps for Vidhajanini. That's really awesome. Really awesome. Now see, kids. Now I'm going to tell you how to write down normal structure into Newman structure. That is really very, very important. See how to write down. First of all, I am giving you this question for you. Just try to understand. This question is very, very important. Question is, try to find out IUPAC name of following structure. IUPAC name of following structure. The following structure is like this, kid. See to it, everyone. Just try to find out, because this is the question which has been already asked in IIT AIMS. So anytime it can be asked in your NEET examination. So this is going to be the best rank deciding question for your NEET examination, NEET 2024. I'm waiting for your answer. One hydrogen is missing over here. So this is also hydrogen. So try to find out. This is being front carbon, that is being back carbon, this is being front carbon, back carbon. What this compound is? Everyone do let me know. Cyclohexane. Inya. Really awesome. Kids, you are really awesome. You are studying on YT and you are doing, your performance is better than most of the offline coaching. That means this time rank is going to come from YouTube. The first rank, I'm thinking for that. This is, yes, this is being cyclohexane. This is none other than cyclohexane. Now try to understand rest of other students how the answer is being cyclohexane. Just see, this is your front carbon. Can you see front carbon? Can you see front carbon, kids? Now let me draw this front carbon over here. This is being front carbon. So this is being front carbon. This front carbon is attached with the back carbon. Here must be some back carbon. You see, here must be some back carbon. The front carbon and back carbon, they are being attached. Is it okay? Same thing over here. There is back carbon. This is back carbon. And the front, this is being front carbon. This is being front carbon, kids. This is being front carbon, and both of them, they are attached. The front and back. Kids, clear? Now this front carbon is attached with the back carbon as well as with this carbon also. So there is one carbon, you can see there is one carbon. So this is a front carbon, and front carbon is attached with back carbon. So this is being front carbon and this is attached somewhere else, and that is attached with this front carbon. That means this is attached with this front carbon, and the back carbon, you can see this back carbon is attached with one carbon. Back carbon is attached with one carbon, and that back carbon is attached with the back of this, back and back, and all they are attached with two hydrogen. This carbon is attached with two hydrogens. This carbon is also attached with two hydrogens. This carbon is also attached with two hydrogens. So all the carbons, they are being attached with two hydrogens, two hydrogens, two hydrogens, two hydrogens, two hydrogens, two hydrogens, two hydrogens. Kids, everyone is able to understand, and that's why the structure is being cyclohexane. Now, those who are not able to understand, I'm going to tell you from the very beginning, and then I will let you know the conformational isomerism in butane. Then I will let you know the conformational isomerism in the compounds which are going to show hydrogen bonding. And then later on, I will tell you the hydrogen bonding in cycloalkanes, that nowhere you are going to get that thing. Now see kids, how to write down the structure. If I say I'm provided with butane, CH3, CH2, CH2, CH3. So there are two possibilities. Suppose if I say this is your front carbon, if I suppose this to be the front carbon and this to be the back carbon, that's my choice. That's my choice. That is being front carbon, this is being back carbon. So I will draw front carbon with the help of one dot. I will draw front carbon with the help of one dot, and this front carbon is attached with 3 hydrogens. This front carbon is attached with 3 hydrogens. So let me draw the front carbon is attached with 3 hydrogens. So let me put hydrogen, hydrogen, hydrogen. And the front carbon is attached with the back carbon. The front carbon is attached with the back carbon. Let us suppose this is back carbon, front carbon dot back carbon circle, and back carbon is having 2 hydrogen atoms. Back carbon is having how many hydrogen atoms? 2 hydrogen atoms. So 2 hydrogen atoms, let me put 2 hydrogen atoms, 1 hydrogen over here, 1 hydrogen over here. Now this carbon is attached with ethyl also, so I have placed CH2, CH3. So this is n-butane, this is also n-butane. Are you able to understand? Both are being n-butane. Now if I say the same butane, if I'm not considering it like that, if I say kids, everyone see, if I consider this to be the front carbon and this to be the back carbon, even we can go like this also. Are you able to understand? This is your front carbon and this is your back carbon. So I would like to say this dot is being front carbon and this circle is being back carbon, right? Now on front carbon, 2 hydrogen and 1 methyl is there. 2 hydrogen and 1 methyl on the front carbon. There are 2 hydrogens and 1 methyl. So let me place 2 hydrogens and 1 methyl. Now kids, on back carbon, 2 hydrogen, 1 methyl. On back carbon also I'm having 2 hydrogen, 1 methyl. So 2 hydrogens and 1 methyl. See, methyl and 2 hydrogens. So this is also n-butane. I hope that everyone is able to understand. This is n-butane. This is also n-butane. I hope that everyone is able to understand. So should I give you one question, 1 or 2 questions? If you are able to understand, do let me know that everyone is able to understand. Is everyone able to understand, kids? Do let me know. Show me the thumbs up if you are able to understand. Then I'm going to give a question based on this. See, question is, find out type of isomerism. Now the compound is like this. This is the front carbon. And this is the back carbon. Back carbon. So on front carbon, we are having methyl, hydrogen and hydrogen. And on the back carbon, we are having methyl, hydrogen, hydrogen. Okay, this is your first carbon. And the second carbon, this is the front carbon. and this is going to be your back carbon, and the front carbon we are having hydrogen, 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 and on the back carbon I'm having methyl, methyl hydrogen. So this is your compound A, that is your compound B. Do let me know what type of isomerism do you think this compound is being having. Everyone, do let me know what do you think, what type of isomerism these two compounds are being having. I'm waiting for your answer. Everyone, try it out and do let me know. Conformers. So A and B, one answer I got from Abdul Wasit. That is being, they are being conformers. Gets positional. Vidhajanani is saying these are being positional isomers. Oh, great. So let me write down the options. That's becoming interesting. It's really becoming interesting, kids. First option, conformers. Second option, positional isomerism. Positional. So anyone else? Two types of answers we have got. Rishi Sonak is saying yes, sir. Okay, sir. Now rest of others, do let me know. It's really becoming something really interesting. Now let's see how Vidhajanani is saying it is being positional. They are looking like conformational isomers. So let me convert into normal structure. This is front, that is back. The front carbon attached with back carbon. Now front carbon is having 2 hydrogen 1 methyl. Front carbon is attached with 2 hydrogen 1 methyl. Front carbon is attached with 2 hydrogens and 1 methyl. 2 hydrogen 1 methyl, and back carbon is attached with 1 methyl and 2 hydrogens. So this is being n-Butane. N-Butane. It's n-Butane. This structure is being n-Butane. Now let me find out. This is front carbon. Front carbon is attached with back carbon. This is being back carbon. Now front carbon is attached with 3 hydrogens. So simply this is being methyl. This is being methyl. And back carbon is attached with 2 methyl 1 hydrogen. This is back carbon attached with 2 methyl and 1 hydrogen. This is being isobutane. Its IUPAC name is 1, 2, 3, 4. N-butane, simply N-butane, normal butane, or simply you can say butane. And this is being C. 1, 2, 3, 2 methyl propane, 2 methyl propane. Now kids, this chain is of 3 carbon atoms and that chain is of 4 carbon atom. Parent chain, here the parent chain is of 4 carbon atoms and here the parent chain is of 3 carbon atoms. So none of these being the correct answer, though the correct answer will be they are positional isomers or chain isomers. They are being chain isomers. So the correct answer is being they are being chain isomers. See kids, chain isomer, that is structural isomers. So none of you are being correct. Chain isomerism is the correct answer, kids. And that's why I've told you that how to write down the structure, that is important. Kids, let me tell you one thing. 99.9% students, 99.9% students will mark for this question. 99.9% students will mark definitely. 99.9% students really, they will mark their answer. They will mark, or they will go for yes, conformers. They are conformers. Yes, because they are looking like conformers. An examiner has the trap. Examiner will put the trap and you will get trapped. Kids, this was really awesome question. If you liked it, do let me know by showing thumbs up. Yes, sir. This is really awesome question. Bhartan, Shanti, everyone is there, kids. If you liked it, do let me know that yes, this was really awesome question. I want to see in the chat section and hit the like buttons, kids. This is not okay. Everyone hit the like buttons. If you already smashed the like buttons, it's okay. If not, kids, your lovely HSP Baba is over here. And really fantastic thing I'm going to let you know, kids, at least so those who are new, in the starting I have shown you this is being ethane or butane or whatever the structure. You can see ball and stick model. Can you see? Those who are new, they can see this is the structure right now. This is eclipsed form. See, eclipsed form. This is seen by Sawhorse side view mirror, and this is seen by Newman, the front view mirror. Now if you're rotating, see, ding 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 ding, dig 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 dig. This is the free rotation. So both are doing free rotation. Both are being doing free rotation, and this free rotation, for this free rotation, energy available is in the form of thermal or kinetic energy. You can see that these bonds are freely rotating. If here is pi bond, then there will be restricted rotation because pi bond will break and they won't be able to move. See, kids, and see the rotation. This is the free rotation happening by itself. You can see, kids. Can you see? Everyone, do let me know. Can you see? Can you see the free rotation? And they are always moving like this. They are always moving like this. They are always moving like this. This is the free rotation. See, this carbon is freely moving. See, this is freely moving like this, and this is free to move. They are freely moving. See, kids. This one is moving like speedily. This is moving like slowly, but they are free to move. Anyone can move like this. This is seen by Newman. Oh. Okay. Okay. I hope. Okay, come back. See, are you getting my point? Have you ever seen, if I'm going to buy this model from the market, there should not be free rotation because their ball and stick model are completely joined. That's why this is man-made. This is HSP made. I made it just to explain it. Now see, kids. Different conformational isomers are known as conformers, rotamers. Different forms of conformational isomers are known as conformers, rotamers. Now see, kids. One question, one awesome question I'm going to give you. Question is, which will have maximum rotational barrier? So I'm going to give you 4 options. Try to find out correct answer, kids. It's your exam. C2H6, this is being ethane. B is CH3, CH2, Cl, that is being chloroethane. C is CH2Cl, CH2Cl, dichloroethane. And this is being your D, C, Cl, 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 Cl. Kids, do let me know What's your correct answer? What is the answer of this question? I'm waiting for your answer, kids. Everyone, do let me know. I'm waiting for your answer. Do let me know, everyone. I'm waiting for your answer. D. D. Everyone is going for D. So the correct answer is definitely D. Why? The answer reason is because of heavy atoms, maximum rotational energy barrier is there. Now kids, I'm going for second question. Do let me know whether that is true or false. That question can be asked in assertion and reasoning. See, your question is, it has not been possible to separate out different conformational isomers or rotamers it has not been possible to separate out different conformational isomers or rotamers into their individual form, it has not been possible to separate out, in place of separate out there can be another term, or isolate different conformational isomers. So this statement is true or false? Do let me know, kids. Is this statement true or this statement is being false? What do you think? Is this statement true or false? I'm waiting for your answer, kids. Wow. Sudhanshu, Sudhanshu, really, I like this. That very speedily you have given the answer. This is NCERT line. This is exactly the NCERT line, and your answer is absolutely correct. See, this is NCERT line. NCERT line. NCERT line. Now, kids, after this, I'm going to move towards butane conformational isomerism. Are you ready? Are you with full josh? Do let me know, kids. Conformational isomerism in n-Butane. Conformational isomerism in n-Butane. And you have to watch it properly, kids, if you want to get full marks. Conformers in n-Butane. So this is your n-Butane, CH3, CH2, CH2, CH3. And let me consider this is your front carbon and this is your back carbon. So from where to where rotation I am supposed to carry out? 1, 2, 3, 4. So rotation, I will do the rotation in between carbon 2 and carbon 3. Is everyone ready? Carbon 2 and carbon 3. The rotation I am going to make and try to understand. Let us suppose this is being front carbon. This is being your front carbon and this front carbon is attached with three hydrogens, or what to say, not three hydrogens, because the front carbon is attached with two hydrogen and one methyl. Two hydrogen and one methyl. Let us suppose this is being methyl and these are being two hydrogen atoms. Now let me draw the back carbon, and I would like to say the back carbon is attached with two hydrogen and one methyl. So this is being one methyl and these are being two hydrogens. Could you please let me know this bulky group and this bulky group, both the two bulky groups, they are far away or they are nearer to each other? Do let me know. Are they far away or nearer to each other? Do let me know. These two bulky groups, they are far away or nearer to each other? They are far away. When they are far away, that means each atom is too much far away from other atoms. So the van der Waals strain in this compound, van der Waals strain is being minimum and the torsional strain will be minimum, because this is the bond angle and this is being maximum bond angle. So we will say this is being staggered form and these two methyls are anti to each other. So we will say this is being anti-staggered form, anti-staggered form, right? Why anti-staggered? Because two methyls are just opposite, because two methyl are anti to each other, It's everyone is able to understand. Now if I hold the front carbon and I start rotating the back one, although the front as well as back both are rotating continuously, but if I hold front and start rotating back one, see, if I say this is methyl, just see, this is methyl and this methyl is over here, rest of others are hydrogens. So the front methyl and the back methyl, you can see they are just, this methyl is over here, you can see this methyl, this back methyl is over here up, and the front methyl you can see is here. Can you see? This is the anti-staggered form. If I keep constant the front one and I start rotating back one, just see when you are going to get the conformers. Kids, everyone is able to understand. I am new to your session. Gayatri, first of all, subscribe this channel if you're liking it and hit the like button. That is the first priority thing. And right now I am telling you conformational isomerism, and this is homemade and this is the best. I have number of conformers, I have number of models which I have purchased from the market, but none of them is that valuable. This is just two potatoes and the spoon and the stick. That is my efforts. Whatever I have got from the kitchen, I have tried my level best. I'm not going to cry for the things that I don't have this, I don't have that. Whenever something hurts you, there are two options. You can either become wounded or you can become wise. So I'm never going to be wounded. I'm always going to be wise. Now see kids, everyone see. Now what I'm saying, just keep this front constant and back when I'm rotating. See, just try to understand. Ding, 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 ding. Repulsion is increasing or not? This atom and this atom will become nearer to each other. Tick, 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 tick. Now you will say this is eclipsed form, but this is not fully eclipsed, because you can see this plum. Can you see this plum? Is this plum visible to all of you or not? Yes. So this is eclipsed but not fully eclipsed. You try to see kids, just try to see, is it visible? Is it visible to all of you? Do let me know. Hey kids, Gayatri, Kalyan, do let me know. Hey, everyone, do let me know. This model is, can you see? Yes. Ritvika, Kanan, yes. Now see, this is eclipsed form, but not fully eclipsed. Now this is staggered. Oh, this has gone. This is staggered, but not anti-staggered. Why not anti-staggered? Because this methyl and this methyl, wow, Priyanka, nice visualization. Thank you, Priyanka. This methyl and this methyl are nearer. See, when it was like this, they are, when it was like this, very costly plum. Right now, plum that is 200 rupees per kg. But I have taken from the fridge just for explaining you kids. At this form, this was the most stable form. This is anti-staggered form. I will draw it on the board, anti-staggered form. Now, if I keep on rotating the back carbon, you can see this is eclipsed but not fully eclipsed. You can see the plum because this is methyl and that is front one is hydrogen. Now it's keep on rotating by 60 degree. I am rotating by 60 degree. Now you can see the front plum is visible. The front plum, the Princia is there. Front plum can you see, but the back plum you can't see. This is the Sawhorse representation and this is the Newman's projection. Newman's projection, the back methyl is not visible. This is your fully eclipsed form. You can see this is this. Somebody is seeing it from the aeroplane or from the helicopter. This is Newman sitting at the roof, and this is you are Newman in front of you, and this is Sawhorse representation. Sawhorse representation. That see, this is the 3D models. Rishi Sonak is liking very much. Kids, just appreciate my efforts. Two potatoes and plums. I'm doing this, kids. Now, there are infinite conformers. You can see there are infinite conformers by rotating by any angle, but this is being more stable, that this bulky methyl and this bulky methyl, they are far away from each other. That is the anti, and this is the least stable form that is being fully eclipsed. Kids, fully eclipsed. Deepa Agajendra is there. So this is fully eclipsed form, kids. You call your friends. I'm doing such much effort, so many efforts. If you're liking it, you must be having your friends. Call them that sir is really doing fantastic efforts, kids. I'm new to YT, but yes, I'm making my best efforts. Thank you, Vedha Janani. Thank you, everyone. Now, see, kids, whatever I have shown you, 3D model, I'm going to tell you, sir, using tomato. Tomato, kids, tomatoes are really the price, more than 200 rupees kg. Madhavan Madhu, right now, tomatoes price is more than 200 rupees per kg. Otherwise, I must have used. Next time, I will try something else. Next time, I will 230 rupees kg. Oh my God. See, Rishi Sonak is saying, oh, yeah, definitely. Now, see, I'm going to draw these structures. Now, see, kids, n-Butane. Just try to understand n-Butane structure. Now this time I'm going to use single pen, single color. Just see, because examiner will use single color. So this is methyl. This is hydrogen. This is being front carbon, and this is being your back carbon. Methyl, hydrogen. Now I have done the rotation by 60 degree. Let's do the rotation by 60 degree. 60-degree rotation. By doing the 60-degree rotation, let us suppose the front carbon is like this only. Let me make the front carbon like this only. This is your front carbon, and rotating by 60-degree the back carbon clockwise. Let us suppose clockwise. I am rotating clockwise. Then this hydrogen will collide with this hydrogen, right? This hydrogen will collide with this hydrogen, so it will come over here. Now this methyl will come over there, but methyl will be visible. Why? Methyl is being more bulky, and this hydrogen will come over here. Agreed, everyone? Everyone agreed? So can you see this is fully eclipsed or partially eclipsed? Yeah, we should be Ambani to buy it, Shiva Kumar. Yes. Now, kids, do let me know, is this fully eclipsed or partially eclipsed? What do you say? Is this fully eclipsed or partially eclipsed? Partially eclipsed. Now, once again, 60-degree rotation, kids. Now, once again, 60-degree rotation. Let's keep the front carbon like this only. Front carbon like this only. Methyl, hydrogen, hydrogen. This is being methyl, hydrogen, hydrogen. 60-degree rotation clockwise. So just do let me know, just try to find out what we are going to get. If I rotate by 60 degrees, this hydrogen will come over here. See, just see to it, everyone. This hydrogen will come over here. This hydrogen will come over here. This methyl will go at this position, and this hydrogen will come over here. Do let me know, everyone. Are you able to understand it or not? This methyl, this hydrogen, and this hydrogen, what do you call it? Neither it is anti-staggered nor it is eclipsed, partially eclipsed. It is simply staggered form. It is simply staggered form. Let me number it so that we can easily find it out. This is the first form. This is being the second form, because examiner will ask the question. And this is being the third form, and definitely I will ask the question. Now once again, 60-degree clockwise, 60-degree rotation clockwise. Now let's keep the front carbon as it was. The front carbon as it was. This is being methyl. These are being hydrogens. Methyl, hydrogens. Now if I rotate by 60 degrees, this methyl, just to let me know, this methyl will come definitely with the methyl, isn't it or not? Methyl will come along with methyl, and hydrogens will come. Just, it is what do you call it, kids? To let me know what you are going to call it. We will call it fully eclipsed form. Fully eclipsed form, right? And this is being the fourth structure. Fully eclipsed. This is going to be least stable or not? This is going to be least stable or not? Then once again, a rotation by 60 degree, what you are going to get? 60 degree clockwise rotation, kids. The front carbon remaining like this, and the back carbon, kids. Everyone, are you able to understand or not? So here what we are going to get? We are going to get a staggered. We are going to get a staggered, and let me call it a staggered form like fifth. And then once again 60-degree rotation, you are going to get the same structure or not? 60-degree clockwise rotation, you will get the same structure. Am I right or not, kids? So this will come over here. No, partially eclipsed. It will not be like that. It will not be like that. We are going to get once partially eclipsed. See, kids, here 60 degree, we are going to get partially eclipsed. Partially eclipsed. This is being, let's say, sixth structure, partially eclipsed. Partially eclipsed. And then by 60-degree rotation, we are going to get the same structure, 60-degree clockwise rotation. So kids, this is being sixth form, this is being fifth form. If you are going to write which is being more stable, so I will let you know which is being Gauche. Kids, first of all, do let me know that if I write stability form, what I should write? The stability is like, suppose which one is going to be most stable. So the most stable is this one. First form is most stable. After first, which one is going to be stable? See kids, not that one, this one. This is 3, 3, and this fifth. 3 and 5 are equal. 3 and 5 are exactly equal. Then partially eclipsed, 2 partially eclipsed, and 6. 2 and 6, 2 is equal to 6, and later on at the last fully eclipsed, this is being fourth structure. Fourth structure. Agreed or not, kids? Do let me know. This I have written for stability. So this one is anti-staggered. This one is your anti-staggered. Anti-staggered, the most stable form. Anti-staggered is being most stable because van der Waals strain is minimum, torsional strain is being minimum, and this is going to be least stable. Fully eclipsed van der Waals strain is going to be maximum, and torsional strain is going to be maximum, so least stable. Anti-staggered and fully eclipsed, whatever the forms lie. One kid has asked about Gauche form. Fully eclipsed means least stable and most stable. Whatever the forms lie in between most stable and least stable, most stable and least stable, they all are known as Gauche form. Gauche. They all are known as Gauche or skew forms. Skew forms. Everyone is able to understand, kids? Do let me know. Yes, you got it. Now, Manish, let me tell you whatever the questions we are going to do right now. Same type of questions. Don't ask that from which topic they are going to ask maximum, because they are mixed questions. So you have to understand each and everything. This conformational isomerism is going to hold a hell lot of weightage. And the most important thing, let me tell you, kids. So everyone is, let me ask one question based on it. See, one question based on this. I'm going to ask one question. Try to understand. Question is, by what angle rotation must be carried out in n-Butane, that is normal butane, to get most stable conformer, from least stable conformer, from least stable. Last time Betha Janani has given the correct answer. Let me check it out. This time who is going to give? Sir, here which is Gauche? In here, in between most stable and least stable, whatever the conformers, infinite conformers are there, they all are known as Gauche or skew. In here, have you got the answer? In between most stable and least stable, whatever the forms are there, they are Gauche. Vedha Janani is writing 180 degree. 180 degree. Let me check it out whether Vedha Janani's answer is right or wrong. This is your front carbon, and front carbon is attached like this, and this is being your back carbon. This is being your back carbon, and back carbon is attached like this. Least stable, we are in need of this most stable from least stable. So this is going to be most stable form. This is going to be the most stable form, and we are supposed to prepare this most stable form from the least stable form. What is going to be the least stable? This is your most stable, this is required one, and we are supposed to prepare it from the least stable form. What is being least stable form, kids? Least stable form is like this. This is, let us suppose it's like this, it's like this, it's like this, and we are having methyl over here, hydrogen at this place, hydrogen at this place, and you can see very clearly that we are in need of compound like this. This is being eclipsed form, this is being your eclipsed form. Now these are being hydrogen atoms, hydrogen, and methyl. So this is your fully eclipsed, that is being least stable, fully eclipsed, least stable, and that is being your most stable. So you see, this methyl from here to here you have bring from this position to this position. So Vedha Janani's, Manish, everyone's answer is being correct. That is 180-degree rotation is the correct answer. Everyone got it. Now kids, what do you think? That person should remain far away, this is good, or they should lie closer to each other? What is good? Do let me know, kids. Which thing is better, that human beings should remain far away? One human being, let us suppose this is Ramu, and this is being, let me change the name, this is not Ramu, let us suppose this is Shahrukh, and this is being Salman. What is good? They should remain far away from each other, that is good, or nearer, that is good. So we will say far away is better, Now if I say this is Vicky, and this is being Katrina, Vicky and Katrina, what is better? They should lie far away or they should lie closer to each other? What is good? So they should lie close to each other, because so this is something, force of attraction is better, and there is force of repulsion is better. So in this world there are just two things, force of repulsion, force of attraction. And in your chemistry, this force of attraction is intramolecular hydrogen bonding, So always remember, kids, whenever in compound intramolecular hydrogen bonding is there, that is going to provide stability. So see, kids, staggered is stable. Generally, what I'm saying, generally staggered form is more stable. Generally staggered is more stable than eclipsed. Generally staggered than gauche, and then eclipsed. This is the stability order, kids. This is the stability order. Are you agreed? This is the stability order. But do remember in case of intramolecular hydrogen bonding. Do remember in case of intramolecular hydrogen bonding. What will you say, kids? Which is going to be more stable? Do let me know what you are going to say. So do remember what I am going to tell you, that is going to play a very, very important role. Gauche will be more stable. Gauche will be more stable than staggered, then partially eclipsed, then fully eclipsed. This is going to be the stability order, kids. Always we have to follow it. Why it is like this and how to find out whether the compound is having intramolecular hydrogen bonding or it is not having. Try to find out. I'm going to give you the trick. First of all, let me tell you which atoms can form hydrogen bonding. Do remember, I'm going to let you know, kids, the most important thing. Hydrogen attached with FON, FON, or C triple bond C can form intramolecular hydrogen bonding or intermolecular, or simply I can write hydrogen bonding. What type of hydrogen bonding? That can form hydrogen bond with FON call, FONCL. Do remember hydrogen, which is either attached with fluorine, oxygen, nitrogen, or triple bonded carbon. Because why? See the electronegativity. If I'm going to talk about electronegativity, it is being 4, this is being 3.5, this is being 3, and this carbon, because it is being sp hybridized, it is 3.25. This carbon is being more electronegative than nitrogen, even more electronegative than nitrogen, kids. Are you able to understand? So they can form hydrogen bonding with FON call. Can you remember FON and FON call? This is a trick. Just if you are having a FON, you can do FON call. This is the trick. What is the trick, kids? Do let me know. If you're liking my trick, do let me know by showing thumbs up. Hey, with FON, can do FON call. FON is like FON, FON. If I don't know the spelling of FON, I will say this is the spelling. Hey, with FON can do FON call, What is FON call? FONCL. So this is the trick. Awesome trick. Do let me know if you're liking this trick. This is HSP Baba's magical trick. Everyone is liking it. Now see how to find out in the examination whether the compound is going to show conformational isomerism. That conformational isomerism, Gauche form, is more stable. Whenever you get compound like this is carbon, see. So this carbon's, this valency, just focus on this valency. Whatever is there doesn't matter. There is R2, whatever is R2 doesn't matter. But if this is X, this is Y, we have to focus on these atoms. The one is being X and the one is being Y. They should be having intramolecular hydrogen bonding with them. If there is intramolecular hydrogen bonding, definitely its Gauche form is going to be more stable. Its Gauche will be more stable than staggered form. So what are these compounds, how they looks like, and what the examiner is going to give in exam? See, once examiner has given compound like this, CH2OH, CH2OH, this is ethylene glycol. Just try to find out whether it is having intramolecular hydrogen bonding or not. Kids, do let me know. Ethylene glycol. So there is intramolecular hydrogen bonding. Once this compound has been asked in the examination, so second time they have given question like this, CH2F, CH2OH, this compound was given. So just try to find out, is there intramolecular hydrogen bonding? Yes, there is intramolecular hydrogen bonding. So in these compounds, Gauche form is going to be more stable. Manish, thank you. I have been studying in a reputed national coaching, but not so much clarity in the concept till now. You have enhanced my concept. Thank you. Manish, see, I'm teaching over here with full dedication. And I'm not skipping even a single word. Whether the thing is given in your NCERT or it is the missing part of your NCERT, I'm telling both the things from the last 23 plus years. Kanishka Yadav, the first rank, substitution elimination reaction, she has just covered in 2 hours the whole type of reactions at the last revision time. The first rank, 715 marks. Mehak Arora, AIMS third rank, All India. Chaitanya Mittal, AIMS fourth rank. Mehak Arora's younger brother, Suyash Arora, 715 marks. All India, 5th rank. At that session, that year, 18 students, they have got 715 marks. So, from that time, I'm teaching each and everything. So, this is the real thing that you are going to get in your examination, kids. In these forms, definitely, your Gauche form is going to be more stable than staggered form. This is the stability order, kids. You have to follow it. You have to understand it. That is going to be change your future. Stability order. Now kids, I'm going to tell you something, molecular orbital theory and the rank deciding things. Are you ready everyone? Do let me know. Now I'm going to tell you conformational isomerism in cycloalkanes. Are you ready for that? Everyone do let me know. Are you ready for that? Conformational isomerism in cycloalkanes. Conformational isomerism in cycloalkanes. Conformational isomerism in cycloalkanes. Now see kids, if I draw cyclobutane, what do you think? Is it planar? What do you think? Is it planar? If I draw cyclopentane, what do you think? Is it planar? Cyclobutane, cyclopropane, what do you think? Cyclopentane, are they planar? Cyclohexane, are they planar? What do you think? Are they planar? They looks like to be planar, but they are not planar. These two are nearly planar. Nearly planar. These two are being nearly planar. and this is not planar. So maximum question you are going to get on this compound only, that this is not planar. So maximum questions will be asked on cyclohexane. Now, why this is not planar? This is having a little bit butterfly structure. Let me tell you what exact structure is there for this compound. See kids, if I draw it like this, then all the hydrogen atoms will be in one plane. And if all the hydrogen atoms are in one plane, then there will be maximum van der Waals strain and maximum torsional strain. So this compound lies like this. This compound lies like this. Try to understand. I'm going to draw a figure and I will explain you definitely. It's this structure is somewhat like this. Now, if this is like this is the, suppose if I draw cyclobutane like this, if I draw cyclobutane like this, zoop, not able to understand. Let me draw 3D diagram, cyclobutane's 3D diagram. So you must be thinking cyclobutane is like this. Try to understand. According to you, cyclobutane is like this, isn't it? Do let me know. Till now you must be thinking that cyclobutane is like this. Cyclobutane you must be considering like this only. See kids. According to you, cyclobutane you must consider like this only. Just to let me know. Kids, do let me know. Kids, do let me know. In the chat section, I want to see. Till now, you must have thought that cyclobutane is like this. But if the cyclobutane is like this, all the carbons should lie in one plane. And when all the carbons are lying in one plane, their hydrogens, means each carbon is attached with 2 hydrogens. 8 hydrogens should lie in one plane. Then there will be maximum van der Waals repulsion and torsional strain. Now, cyclobutane, what cyclobutane is going to do, see kids, it's this part will rise a little bit up. Can you see this part? Just see, this part is going, let me make it like this, and this part is going a little bit up. This one part is going a little bit up, so this will go down. Can you see what will happen if this is going up, this is going up, and this is going down? If these two, this carbon is going up, this is going down, this is going down, then there will be less van der Waals repulsion, and these 2 hydrogens will go up and these 2 hydrogens will go down, and this will once again will go up. See, it is like this. Can you understand? Try to understand it. This carbon near to my nose and going away from nose, these 2 carbons are lying up, and the hand which I am holding, the right hand side hand and the left hand side hand, these 2 carbons are going down. So this is a somewhat butterfly structure. This is going to make less torsional strain as well as van der Waals strain. So it is nearly planar. Cyclobutane is not exactly planar. It is nearly planar, not exactly planar. So this is nearly planar. And let me tell you about cyclopentane. You must have seen the envelope which we used to give something during the gifts, as a which is used as a gift, giving gifts, notes, or whatever the things. You see these 4 carbons are lying planar, but one carbon is little bit like this, envelope type. So this is not planar, this is nearly planar. And cyclohexane, let me tell you cyclohexane on the next page. Just try to understand cyclohexane, kids. If I draw one line like this, if I draw one line like this, another line like this, right now this is planar, but just try to understand. If I draw another line like this carbon is going up, and this carbon, just try to understand, this carbon is going down. This is actually cyclohexane, kids. The chair structure, can you see the chair? If I try to draw chair, just try to understand how it will look like, the chair. Just see. I'm going to draw, I'm trying my level best to make the chair. So this is the chair where we used to sit, and this is the part, hood going up, the hood going up. Just try to understand, this hood is going up, and then only the rank deciding question you can do if you are able to understand it. Otherwise, kids, you won't. And this hood is going down, the legs, the leg area, this part is going down. So these are the 6 carbons. Now number of students, they won't be able to understand it, but kids, if you want to get the best rank, the first rank, then you have to understand. Now try to understand the hood which is going up. The hydrogens will be like this. One hydrogen, this is known as axial hydrogen, will be going up, and the another hydrogen will be going down. This will be going down, this is going up, because we have to understand V, 2V, that is being tetrahedral. So this hydrogen must be going up because this hood is going up. So its hydrogen is going up, and this hydrogen will be known as axial hydrogen. Axial. This will be known as axial, and this going down, this going down, this is known as equatorial. Equatorial. This is going down, and this is going up, because this vertex is going up, this vertex is going up, so this axial is up. Now this vertex is going down, this is going down, so this axial will go down, its axial will go down, and the equatorial will go up, equatorial will go up. So this is being axial, this is being axial hydrogen going down, and this is being equatorial hydrogen going up. Now same like this vertex is going up. Just try to understand, this vertex is going up. Can you see, this is going up, 3 carbons are going up. Try to understand, kids, everyone, just try to understand, 3 vertices are going up. This is going up, this is going up, and which one is going up? 1, 2, and 3. These 3 are going up. Can you understand, kids? Do let me know. This is going up, this is going up, and this is going up. 3 carbons are going up, and 3 carbons are going down. 3 carbons are going down. This is going down, this is going down, and this is going down. 3 up, 3 down. Are you able to understand, kids? Everyone, do let me know if you are able to understand. Now let me tell you very important thing. Try to understand, not everyone is able to understand. This is going up, so its axial must be going up, and this is going up, its axial must be going up, kids. This is axial is going up, and equatorial must be going down. Equatorial must be going down. So this hydrogen is going up, and this is being axial, and this is being equatorial going down. Same like this hydrogen, there will be one more hydrogen, because this is also up, if this is also up, its hydrogen will also be going up. You just try to find out, this hydrogen must be going up. Some student must be started feeling pain if they are not able to understand. This hydrogen is going up, this hydrogen is going up, this is up, this is up. Now its equatorial must be going down, equatorial must be going down. Let me draw, equatorial hydrogen must be going down. Now this hydrogen and this hydrogen, these three hydrogens, there will be repulsive force. They will feel repulsive force because there is no hydrogen bonding. So repulsion is there, and this repulsion is known as 1,3 diaxial repulsion. 1, 2, 3. 1, 2, 3. With respect to that hydrogen, these two hydrogens are on the third position. So this is known as, there are total 2, 1, 3 diaxial repulsion. 1, 3 diaxial repulsion. I will tell you the short form of it. I will let you know in short also, but right now try to understand. And 1, 3 diaxial repulsion gives 0.9 kilocalorie per mole. 0.9 kilocalorie per mole. So there are 2. So 2 into 0.9, that is going to 1.8 kilocalorie per mole. So see kids, let me tell you. Right now hydrogens are very small. If I put here CH3, then this repulsion is going to be like this, because hydrogens are being very small, so we cannot compare. So one methyl is there. If one methyl is there, then these are the repulsive forces. Now see how the question will be asked. See kids, if I write methyl cyclohexane, just try to understand kids. This is a question of AIMS, methyl cyclohexane. So how I can write methyl cyclohexane? Just try to understand what is the way in which I can write methyl cyclohexane. This was like this, this was like this, and this is the chair form. I will tell you all the structures of cyclohexane, but try to understand. One is this form, and when it is going to do conformational isomerism, it will look like this. See kids, it will look like this. This part will go down. Let me tell you, if there is methyl on the axial, this will come down, and the thing which is going down, that will go up. So these are the two conformers. This methyl is axial. Now the methyl will become equatorial, and there will be hydrogen. Now try to understand kids, this is going to be really very important. Now see, one conformer methyl is over here on the axial position. So this methyl will feel force of repulsion with these two hydrogens. As I have told you, they are also lying on axial. These two axial hydrogens will put force of repulsion with this methyl. How they are going to put force of repulsion? Let me tell you. This methyl is like this. This methyl is like this carbon, and it's 3 hydrogen atoms. One hydrogen is going over there, one hydrogen here, one hydrogen will come nearer to it, and there will be repulsion. So this is having 0.9 into 2, 1.8 kilocalorie per mole energy. More energy, this much more energy. Now once it has changed to this has become equatorial. Now this equatorial has gone away from these hydrogens. Whatever the hydrogens are present over here, there is no 1,3 diaxial repulsion. There is no 1,3 diaxial repulsion. No 1,3 diaxial repulsion. That means it is having less energy. This is having more energy. This is having more energy. More energy means less stability. More energy means less stability. means less stability. So if examiner is going to ask which is more stable form, this is methyl cyclohexane, axial methyl cyclohexane, and that is equatorial methyl cyclohexane. Equatorial methyl cyclohexane and this is axial methyl cyclohexane. Just to let me know which is more stable. So definitely that is more stable. So the equilibrium will lie like this, more toward that side, less towards this side. So if you're not able to understand anything, just to remember that equatorial methyl cyclohexane is being more stable than axial one. In the examination, do remember, if any R group is on equatorial, that is going to give more stability than equatorial. Equatorial is going to be more stable than axial. What? Equatorial is going to provide more stability than axial. Axial is less stable, equatorial will be more stable. For example, without understanding anything, if examiner, see the rank deciding question, see kids, try to understand, without applying brain, you can do this question. Arrange the following in decreasing order of stability. See kids, this is all about dimethyl cyclohexane. 1,2-dimethyl cyclohexane. One is given as equatorial 1,2-dimethyl cyclohexane. Another one is given as equatorial axial 1,2-dimethyl cyclohexane. And the last one is given as axial 1,2-dimethyl cyclohexane. Now let me know if you are able to understand what I have told you. You can answer it immediately. Kids, do let me know. Even though if you are not able to remember the energy level, if you have forgotten whatever the things, now let me give you one trick. Kids. In my mind, there is one trick. See, E stands for elephant. E stands for elephant. And A stands for ant. Which is more stable? Elephant or ant? This is also having ant. This is all. Who is more stable? Elephant or ant? Kids, do let me know. E means equatorial. A means axial. Kids, do let me know who is being more stable. Elephant is being more stable or ant is being more stable? Who is being more stable? Definitely ant or elephant. Elephant is more stable than ant. So you can find out there are two elephant, only one elephant, all are ant. So A is more stable than B is more stable than C. I hope that everyone is able to understand. This is the best fundamental thing. This is the trick, or whatever you can say. This is being your stability order. Kids, do let me know that everyone, this trick you like it or not. Kids, do let me know if you're liking the trick. I'm waiting for your answer, kids. Hey, everyone. Yeah. So how's the trick? Elephant and ant trick. Elephant and ant trick is good or not? Good enough. Now see. Cyclohexane has infinite conformers. Kids, cyclohexane has infinite conformers because cyclohexane is very, very important. So I have to tell you each and everything. Cyclohexane has infinite conformers. Infinite conformers. Following four are most studied. Following four are most studied. Now, what are following four? First one is being chair form. Chair form. Twist boat. Boat. Half chair. Now, kids, this is the stability order. This is being the stability order of most studied four. Although it is going to form infinite conformers, this is maximum stable. Why this is being maximum stable, kids? Because this chair form has van der Waals strain minimum, torsional strain minimum, because the chair form has approximately 109-degree bond angle, tetrahedral 109-degree bond angle. Twist boat, half chair. Half chair has van der Waals strain maximum, torsional strain that is also maximum. So how they look like? Chair form to already you know. Twist boat looks like this. See kids, this is the twist boat. This is twist boat. This is twist boat. How many carbons are there? How many carbons are there? You will say, sir, number of carbons are there. 1, 2, 3, 4, 5, 6. This is not carbon. This is not carbon. It's twist is there. Now boat, you know very well. This is your boat form. And whenever it is doing conformational isomerism, you know, once the boat is doing conformational isomerism in the river, the pupil will go down. Right now, pupil are up, boat is down. When it is going to do conformational isomerism, people will go inside the water. Conformer. Half chair is like this. This is the half chair form. So this is conformational isomerism in cyclic forms. Are you able to understand? Do let me know that everyone. Best ho sir aap. Oh, Santanu Kumar Nahak. Thank you. Rishi Sonak. Thank you. Kids, everyone hit the like buttons if you're liking this session. And now I'm going to give you a number of questions based on NCERT. Are you ready? I'm going to give you questions based on NCERT. Is everyone ready? Do let me know. Everyone, do let me know. Are you ready? Ready? That's fantastic. Now, see, I'm going to frame out one question from NCERT. Let me check it out. And try to understand it. This question I am going to give you from NCERT. See, this is your NCERT. This is the NCERT, and I'm going to give one question from NCERT. Okay. Question is, you have to tell me true or false, right? True or false. Everyone ready for true and false? Question is, that in all the conformations, in all the conformations, in all the conformations, the bond angles and the bond lengths, the bond angles and bond lengths bond angles and bond lengths remain the same, remain the same. Now you are supposed to tell me whether this statement is true or false. This is the question, and do let me know, everyone. A for true, B for false. Do let me know, what do you think? Is this statement true or false? This question I have framed out from the NCERT. Don't think that whether it is given in NCERT or not. See, I've used NCERT. Kids, do let me know. This question I have framed out from NCERT, NCERT corner or NCERT lines. Do let me know. What do you think? Is this statement true or false? Everyone, I'm waiting for your answer. Hey everyone, fast, quick response. I want to see the quick response. Yes, fast. Do let me know, kids. In all the conformations, the bond angle and bond lengths remain the same. So remember that this question has been asked already. The NCERT lines has been asked in year 2016 that this is true. Yes, Ishmebi is given the correct answer, and your answer is absolutely correct that this is true, and this has already been asked in year 2016. They have asked this question in 2016, kids. This is a really awesome question. Now see, try to understand. If I say that this is cyclohexane, this is your cyclohexane, just try to understand it. I'm going to draw your cyclohexane. Now, this is the foreign writer structure. Foreign writer, they used to draw this structure like this. Our Indian writers, they are going to draw this structure like this. But before that, let me draw this once again so that you can visualize it. This is going up, this is going down, this is going down, and this is the middle part. Just try to visualize it. This is foreign writers, they are going to draw it like this. And our Indian writers, they used to draw it like this. Just try to visualize it. Who is better? Are they talking same or they are telling you different things? Just do let me know, kids. Both are same or different? Just see, that is Indian version. Indians, they used to write like this. In our books, the structure is given like this. And this is abroad books. Just compare kids. Now try to understand. If I say this is front carbon and if I keep my eyes over here, and you just see this is my eye, this is this carbon, these two carbons are these one, and this is the middle part, and that back one is going there. So if you see from here, if you see this structure from here, both are same. This is 3D figure, that is 2D figure, but they are same. This is being 3D figure. This is being 3D figure in this space, and this is being 2D. So Indian writers, what they have done, they have converted 3D figure into 2D figure, and they are drawing it like this. Kids, everyone is able to understand that both mean same. And now Newman has seen this structure like this. What Newman has done, see kids, Newman has drawn this structure like this. This is also cyclohexane. What Newman has done, see everyone, try to understand what Newman has done. 1, 1. Just try to understand. Newman has drawn like this. Newman has drawn it like this. This is the Newman's projection. See kids, this is being Newman's projection, and this is also being cyclohexane. If you try to understand, you will definitely get it. Why is this being cyclohexane? So all three structures, they are exactly same. If I talk about 1, if I talk about 2, if I talk about 3, all they are being same. Now the question part, kids, try to understand and try to understand this question's answer. Simple questions I am going to ask. Question number 1. Which compound will not show conformational isomerism? Conformational isomerism. Your A is ethane, B is isobutane, C is neopentane, D is methane. I want the clear-cut answer, kids. Everyone's answer means a lot, and try to answer it. Your answer means a lot. I'm waiting for your answer. D, that's really fantastic. D is the correct answer. So this was easy question, and methane can't show because it is just having 2 regular sigma bonds. Now next question. This was easy question. So next question is going to be a little bit tough. So question is, by what angle rotation must be done in n-Butane to get least stable conformer from most stable from most stable. So options are being A option 30 degree, B option 60 degree, C option 90 degree, D option 180 degree. What's your answer? Om Sudhanshu is going for 60 degree. Rest of others, do let me know. Vedha Janani's answer is being absolutely correct, that 180 degree. And Karthik Kumar D, or we can say 180 degree. Either you want to prepare most stable to least stable or from least stable to most stable. Both the questions are meaning same. They have same answers. Kids, are you able to understand? Now see, everyone, next question. Question is, strain or repulsion due to bonded electron, first option van der Waals strain, second option torsional strain, third option both, last option none of these. Kids, do let me know what's your answer. I'm waiting for your answer. Everyone, do let me know what's your answer and hit the like buttons. B, Priyanka Arthi, that's really awesome, fantastic. B is being the correct answer. That is known as torsional strain. See kids, such type of question they are going to ask. Now see, I'm going to show you molecular orbital theory, why staggered form of ethane is more stable. That is going to be the rank deciding. See, molecular orbital approach, MOT approach, for stability of ethane staggered form, ethane's staggered form. See kids, this was the ethane staggered form. If you see, this was the Sawhorse staggered form. If you see this regular Y, and let me make this your inverted Y. Can you see everyone? Do let me know. This hydrogen, this hydrogen, this hydrogen, this hydrogen, this hydrogen, this hydrogen. Just try to understand kids. If I say this is being bonding molecular orbital, BMO, bonding molecular orbital, that is being BMO. Can you understand? BMO, bonding molecular orbital. Just at the back of it there must be ABMO, and the ABMO must be vacant. This ABMO must be vacant. ABMO vacant, that is empty. Agreed kids? Empty, or you can say vacant. Now here this is your BMO, this is your being BMO. Just try to understand, having electron, this is being BMO, bonding molecular orbital, and there must be ABMO, that is being vacant, this is ABMO. Now what do you think? Electron wants to remain localized or they want to delocalize? Just like during the COVID pandemic, government said, hey, just remain inside your house. No one is allowed to roam, to wander, to move. At that time, we were feeling difficulty. That time was very difficult time because everyone was localized in their own house. Now, kids, this electron can move to the adjacent ABMO. Can you see very clearly? Try to understand what I am going to tell you, kids. This electron can move towards ABMO. It can go to this ABMO. Are you able to understand? This will go towards this. It will go in this. Once again, I am going to try to tell you. See, try to understand. This electron will go in this ABMO. Once again, I am going to tell you. Try to understand it, kids. This electron will move in this, and this electron will move in this. This you can say hyperconjugation, or you can say stabilization, that this electron can go to this ABMO and this BMO electron can move to this, and that's why staggered form is more stable. Staggered form is being more stable. Now let me tell you the most important thing. What mistake was done by Baeyer? Bayer's strain theory. Let me tell you the most important point. See, kids. Bayer's strain theory and the mistake done by Baeyer. Bayer's strain theory Bayer's strain theory and mistake done by Baeyer. See, Baeyer said that cyclopentane is being the most stable out of all these cycloalkane ring. What Baeyer said, according to Baeyer, cyclopentane was more stable. Now, what experiment this Baeyer has done? See, the experiment done by Baeyer. This is really going to be very, very important, kids. So try to understand it. Baeyer said this is being cyclopropane, this is being cyclobutane, and this is being cyclopentane, and this is being cyclohexane. If you know a little bit of maths, then Baeyer said all they are being sp3 hybridized according to Baeyer. I am not saying that. According to Baeyer, this is being sp3, this is being sp3, this is being sp3, and this is also being sp3. All they are being sp3 according to Baeyer. So if anything is sp3 hybridized like carbon, so the expected bond angle is 109 degree. This is the expected angle, but if you apply maths, this is coming out to be 60 degree, this is coming out to be 90 degree, this is coming out to be 108 degree, and this is coming out to be 120 degree. So if we compare from sp3 hybridization, this is 109 degree, 109 minus 60 degree. How much is the strain? 49 degree strain. 109 degree minus 90 degree. It is 19 degree strain. 109 degree minus 108, just 1 degree strain, and it is having 108 minus 120, that is minus 12 degree strain. So according to Baeyer, this is having least strain, so he said cyclopentane is being more stable. But we know that number of experiments has been carried out, and those experiments says that cyclohexane is more stable. But practically we all know that very well, we know it, but practically, experimentally, that is true. Heat of combustion, that is true. Heat of combustion, it was proved cyclohexane is being more stable. Cyclohexane is more stable, and that time, that means Baeyer got proved to be wrong. Bayer's theory proved to be wrong. Now, what mistake done by Baeyer? Bayer's mistake. See, mistake done by Baeyer. Baeyer has considered all the rings to be planar. All the rings to be planar, which is wrong. All the rings to be planar, and we know that at that time it was proved that all rings are not planar. This is the mistake done by Baeyer, but in actual all rings are not planar. All rings are not planar. So always remember that whenever you are going to do question, let me show you that slide. This is the most important thing that you have to keep it in your brain. No one is hitting the smash button, like button. Smash the like button, kids. Smash and hit the like button, kids. I want the likes to get increased. So always remember, if you're talking about, whenever you're talking about anything in chemistry, that cyclohexane ring is generally more stable than its cyclopentane, and cycloheptane and cyclopentane are considerable, but yes, cycloheptane. So whenever you are going to solve any question, just keep it in your brain that how to arrange in the stability order of rings. So this is being the stability order of rings. And that's why you must have seen, whenever we are studying any chemistry part, that we used to say that whenever we are provided with compound like this, carbocation, the four-membered ring is going to do ring expansion, and the four-membered ring will convert into five-membered ring, because from four-membered ring, five-membered ring is more stable, and this is the ring expansion, and the four-membered ring will convert into five-membered. This is known as ring expansion. Now, if we are provided with five-membered ring, then definitely more than five-membered ring, the six-membered ring is more stable. So this will do the ring expansion like this. This carbon will go and join bond with this, and this ring expansion will convert five-membered ring to six-membered ring. This is also ring expansion. But my dear friends, remember that three-membered ring, if anyone is provided with this three-membered ring, never convert this three-membered ring into four-membered ring. Why? What's the reason behind it, kids? What's the reason behind it? This is more stable ring than that. This ring is stabilized by dancing resonance. This ring is stabilized by dancing resonance. Dancing resonance. Dancing resonance. Dancing resonance. And the most important thing that everyone must be thinking that this carbon is sp3 hybridized. Wrong. This carbon is not sp3 hybridized. This carbon is sp4 to sp5 hybridized. Now you must be thinking, sir, have you lost your brain? What are you talking about? Yes, kids, this is sp4 to sp5. This is given in your J.D. Lee book, J.D. Lee best chemistry book. Every book it is given. I will let you know later on, but yes, this is sp4 to sp5 hybridized. So definitely this ring will convert into this. This is known as ring contraction. This is known as ring contraction. Always you are doing ring expansion. This is ring contraction. This is ring contraction. I will not say that it will totally convert into this. Some part will remain on that side also, because 51% lies toward this side and rest of the elimination takes place. 47% like this side plus 47, 51, 2% elimination takes place. Now kids, this is very important things I've told you. Now I'm going to tell you rank deciding concept. Is everyone ready? Already ready? The rank deciding concept, the most important thing I'm going to tell you, kids, try to find out, and this is going to hold a hell lot of weightage. So rank deciding means, now I'm going to tell you rank deciding, and this is for top 50 rank, top 50 rank, for top 50 rank, that is target is AIIMS Delhi. AIIMS Delhi is being the target. Now see kids, if I draw a compound like this is being nitrogen, and if I add 1 valency, 2 valency and 3 valency, and all they are being different, let us suppose if one is being methyl, another one is being ethyl, and another one is suppose isopropyl CH3, or I can write hydrogen, even hydrogen. Now just try to find out, all the four groups are being different. This is one lone pair treated as group according to CIP rule 1, 2, 3. So all four groups are different. So what I'm going to tell you, this nitrogen is being chiral nitrogen, and if there is chiral nitrogen or chiral carbon, this compound is not having plane of symmetry. No plane of symmetry, no center of symmetry, no pos means plane of symmetry, no cos means center of symmetry. So this compound is optically active. Compound is optically active. Compound is chiral, asymmetric. Now kids, what do you think? Will it show optical isomerism? Will it show optical isomerism? What's your answer? But still it can't show isomerism. But still can't show optical isomerism. Why? Kids, why? The answer is it will do conformational isomerism. This will do umbrella inversion and this will convert into this form. This will convert into this form: nitrogen, methyl, ethyl, hydrogen. This is known as umbrella inversion. So this form will convert into that form, although it is being chiral, although it is having no plane of symmetry, no center of symmetry, and this compound will convert into this compound. And that's why this compound, although being chiral without any plane of symmetry and center of symmetry, this is the conformational isomerism, and this is known as umbrella inversion. Umbrella inversion. And why this is not going to, we are not saying that it is going to show optical isomerism. We know that optical isomerism is the part of configurational isomerism. Let me tell you, optical isomerism is the part of configurational isomerism. Optical isomerism is configurational isomerism. What do you mean by configurational isomerism? The isomers which can be separated. Configurational isomerism means what? Those isomers which can be separated, isolated or separated. That means dextro and levo can be separated. Dextrolactic acid, levolactic acid, dextroglucose, levoglucose, they can be separated. But we are saying that these two forms are interconverting. That means they are conformers, and conformers can't be separated, whereas conformational isomers, kids, whereas conformational isomers can't be separated. This is the main difference. That's why this is really the best question. Now, this is not the full truth. If the question comes like this is nitrogen, there is one phenyl, one methyl phenyl, one, say something else, OCH3 is there. Now also the carbon is being, this nitrogen is being chiral, but these are heavy groups. You know, when you are having umbrella, just see, if you are having umbrella like this, and once the wind is coming, this is your umbrella, a wind is blowing, this umbrella will convert into like this. With the wind flow, the umbrella will convert like this. So this is known as umbrella inversion. Amine inversion has taken place, umbrella inversion. But kids, if we put support, weight, if we put some weight over here, like if I put some weight over here, suppose if I've tied it with this stone, heavy stone. Now, what do you think? Umbrella can do inversion? No umbrella inversion. Because of heavy weight. Heavy weight is there. So you see the heavy rings, due to heavy rings, can't do inversion. Can't do inversion means can't show conformational isomerism. Can't show conformational isomerism. Can't show conformational isomerism. So this can be separated and will show optical isomerism. So definitely will show optical isomerism. Optical isomerism. One more question, let me tell you. The last one. See, rank deciding. Kids, everyone is liking it. Hit the like buttons if you're liking it. Everyone do let me know if you're liking it. Hit the like buttons. Now see, kids. If the question is like this, which is being more basic, which is being more basic, one compound is like this: nitrogen, CH3, hydrogen, ethyl, C2H5. And the question is being like this: this is A and this is B. Which is being more basic? Do let me know, kids. This is being A, this is being B. This is mind-blowing question and rank deciding question. This is going to be the rank deciding question. This is the last question for today's lecture. Or if you are able to do it, then I will give you 3 more questions. If you are able to do it, if you are able to find out the correct answer, then I will give you 3 more questions. Otherwise, I will not. If you are able to give the correct answer, then I will give you 3 more questions. Kids. I'm waiting for your answer. And at least make these likes to go up to 70. Right now 66. At least it should touch figure of 70, kids. What are you doing? You're not liking HSP, Baba. That means A is more basic. So kids, is there anyone who is going to tell me the correct answer? Everyone is going for A. Let me tell you the answer. The correct answer is B is being more basic. Now, is there anyone who is going to ask why B is being more basic? See, kids, this nitrogen will do umbrella inversion, amine inversion like Jackie Chan. Like Jackie Chan, this will do umbrella inversion. It will do umbrella inversion, amine inversion. See, right now, if any proton is going to attack on the lone pair, let us suppose this is the head and the proton is going to attack on this. This will do the flipping like this. So now the proton is going to attack over here. It will go like that. This is known as amine inversion, kids. This is known as amine inversion, flipping. Amine inversion, I can say. Flipping word I can use. Or conformational isomerism I can use. Now kids, this cannot do amine inversion. Why? Question arises why it can't do amine inversion. Can't do amine inversion. Can't do amine inversion. Now question arises why? Kids, for doing amine inversion, let me first tell you how the amine inversion takes place. Then only you will be able to understand. This is nitrogen and this is attached with 3 valencies. 1, 2, 3. R1, R2, R3. R1, R2, R3. Just try to understand. This is being lone pair. So what is the steric number of it? Steric number means number of sigma bond plus lone pairs localized. Yes. Number of sigma bonds 3, lone pair 1, 4. So the hybridization is sp3 and this is pyramidal in shape. Am I right? Pyramidal in shape. Suppose, just see to it, if my hands are down and if I am going to bring them up, in between up and down, the hands will come like this. A time will come, they will be planar. See, my hands are down, my hands are up, two extreme conditions, up, down, but up and down there, it has to be like this. It's one time it has to come planar, then only it can go up and down. See, this is down, this planar, this up. So while doing the umbrella inversion, this is its umbrella inversion. Now see, R1, R2, R3, R2, R1, this is also pyramidal. But moving from this form to that form, it should have to become planar, like this. One state should be like this, highly unstable position. This will be planar at this time. At this time, its lone pair is not going to occupy maximum space. Valence shell electron pair repulsion theory says that lone pair has to occupy maximum space, but there is no space, and this is being sp2 hybridized because this has become planar and this is being highly unstable form. Highly unstable form. So this is the transition state by which these two forms are interconvertible. These two forms are being interconvertible, that this form is going to convert into that form, this form is going to convert into this form, but this is being transition state. If I show the graphical portion, if I draw the graph for it, the graph should be like this. This, the two forms, let me tell you, this is the energy, this is the energy, then the two forms should look like this. This is pyramidal form, this is pyramidal form, and this will convert into that, this pyramidal form. Let me say this is being X, this is being Y, and this is being Z. X is converting into Z through the intermediate formation, that is being Y, and this Y is being having maximum energy. This is being sp2 hybridized, and both of them, they are being sp3 hybridized. So this is the path through which it has to move, it has to suffer. Now why, sir, you are telling all these things? The question was something else. Why you are telling us these things? This is having the reason, and this is the base. Just try to understand. Everyone try to understand. This can't be planar. This can't be planar. Why it can't be planar, kids? It can't be planar according to Braddock's rule. According to Braddock's rule. What Braddock's rule says? Braddock's rule says any atom which is attached to bridgehead carbon, bridgehead atom can't be sp2 hybridized. Bridgehead atom can't be sp2 hybridized. Bridgehead atom can't be planar. This is said by Braddock's. So it cannot do amine inversion. Like suppose somebody is going to hit my head, I will do gym like Jackie Chan. I will rotate, I will start rotating, head down, head up, head down, but somebody is going to attack on the head of nitrogen. This cannot do amine inversion, and proton will easily attack on this lone pair. This lone pair cannot move, this atom cannot move. That means this is going to be easily attacked. So I will say this is mobile, this lone pair is mobile, can move, and this is immobile, can't move, Now you know very well that if you want to hit mosquito, if in your area there is mosquito, in your room there is mosquito, one mosquito is sitting on the wall and another mosquito is flying with very high speed. Which mosquito you are going to kill easily? Gets to let me know. The one who is localized sitting on the wall, you can hit that mosquito easily, or the mosquito which is flying with high speed, that mosquito can be easy kill. Which mosquito is easy kill? Definitely the sitting one. So this is sitting mosquito and this is moving mosquito. This lone pair you can consider, this lone pair can be considered, this lone pair is like, this lone pair is like moving mosquito, moving mosquito, and this lone pair is like sitting mosquito. This lone pair is like sitting mosquito. So easy kill. Kids, you like this topic? No one is going to tell you this topic, and that's why number of times kids are going to get failed, because this topic, mind-blowing thing, is not given in NCERT, but number of questions has been asked number of times in your previous examinations, whether I talk about IIT, I talk about AIMS, and if I talk about NTA. Hidden things are there, and that's why we always say that NCERT writes in between the lines, and we have to understand each and everything if we want to gain full marks. Kids, do let me know. So I will give you 3 questions, and these 3 questions you have to tell me. 2 questions right now you have to tell me, and 1 question is will be for your homework. Thank you, Shivakumar. Thank you. 1 question will be for your homework. 2 questions right now you have to do. Agreed? Ready, everyone? Do let me know. Do let me know. Now see. Question number 1. Question number 1. See, kids. How many compounds will show conformational isomerism? How many compounds will show conformational isomerism? A. Ethene. Not visible, let me write down once again. A. Ethene. B. Propene. C. Acetylene. D. Benzene. E. Toluene. F. Ethanol. G. Methane. H. Water. I. Hydrogen peroxide. J. Ethane. Just try it out. I will give you the options. Right? These are your options. Just try it out and do let me know what is your answer. Really fantastic, awesome question. Let me check it out what answer you're going to give, kids. I'm waiting for your answer. 5. Shubha Kumar is saying 5. If this answer is going to be correct, definitely I will clap for Shiva Kumar. I don't know this is right answer or wrong answer. I will definitely say then stupendous performance. I will feel accomplished if your answer is going to be correct. So really awesome that what I can see, this cannot show. Why? It is having carbons attached with double bond. But propane will show. Why? These hydrogens are attached with sp3 hybridized carbon. So this cannot show, but this can show. Yes, acetylene, they are attached with pi bonds, so cannot show. No, benzenes, so all the carbons are attached with, see, these are doubly bonded, cannot show. Toluene, yes, one is being CS3, that can move. That's why it shows hyperconjugation. Ethanol, yes. Methane, no. Hydrogen peroxide, yes. Water, no, 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 no. This, yes. This, yes. How many compounds? Yes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this C option is correct. Congratulations, and Shiva Kumar, you have given answer so fastly, so quickly. Congratulations. So claps for all these students. Your answer is absolutely correct, and you are rocking, kids. Definitely you are rocking. Let me tell you that these are those questions that not an average student is going to answer it. Really, congratulations. Kudos. Now see, kids, second question. Second question right now you have to do, and the third question will be homework. See, second question. True or false? Question is for true or false. Staggered form is always more stable. Staggered form is always more stable. A option true, B option false. Do let me know what is correct. I'm waiting for your answer. True or false? False. Wow. Vidhajanani. Vidhajanani's answer is absolutely correct. That false, because in case of intramolecular hydrogen bonding, Gauche is being more stable. Gauche is more stable, right? So that's really fantastic. Now one question for your homework, right, kids? Really, today I have told you each and everything, but 68 kids, at least make it 72 more likes. I need 2 more likes, that it should be a good figure. 70. Could you please do that? Is it possible? Is it possible? Could you please do that, kids? Make it 70, and I'm going to give you question for your homework. Homework question. You have to not to give the answer right now. Homework question later on in the comment section. I would like to see this question's answer. Homework question. Question is, IUPAC name of this compound. IUPAC name of this compound, and the compound is, this is the front carbon, this is back carbon, and front carbon is like this, attached with this hydrogen, 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 hydrogen. This is your compound. Can you see clearly, everyone? Soumya, Deep Bhomik, wow. Kids, this is your question. This is question for homework, and you have to try. So just try at your home and try to find out what should be the answer of this question. Kids, I have given it for homework. This is really a great question, and you will really enjoy while giving answer of this question. This is your question. Kids, can you see the question? Is it visible to all of you? Okay, I will wait for your answer. IUPAC name of this compound. The question is the IUPAC name of this compound. IUPAC name. IUPAC name for given structure. For given structure. I will see the comments and I will reply over there. Just try it out. It's not ethylene, no Soumyadeep. This is question for your homework, and everyone is supposed to give the correct answer in the comment section. Kids, do let me know. 69. Right now it's 69. Make it 70. Only one like is required, kids. Only one like is required. And this is the question for your homework. Everyone is supposed to do it. Do it. Try it out. Really, you will enjoy it a lot. It's definitely. I'm sure that you will enjoy. Kids, everyone. Oh, 70. You made it 70, kids. Now, do let me know. The next topic on your YT, I will teach nucleophilic substitution reaction, and that is going to be the part of 12th chemistry, right? Now you must be thinking, sir, what about purification of organic compounds? Purification of organic compound, environmental chemistry. I will teach each and everything. I'm not going to leave anything, but these are simple kill topics. I will consider these topics at the last, right? Once, let me tell you the schedule. Let me tell you how I am going to tell you, how I am going to teach you. First, I will consider all type of reactions. That is being substitution reaction first, then elimination reaction, then addition, and substitution reaction. I will divide in three parts: nucleophilic substitution, electrophilic substitution, free radical substitution. And nucleophilic substitution I will divide in four parts. What are these four parts? SN2, that bimolecular nucleophilic substitution reaction; SN1, unimolecular nucleophilic substitution; ARSN2, aromatic bimolecular substitution, ARSN1. So these are the type of, yes, nucleophilic substitution reaction. And electrophilic substitution, I will consider the whole NCERT. So next topic will be your, yes, what should be the next topic? Next topic will be your nucleophilic substitution reaction, and that is bimolecular nucleophilic substitution reaction SN2. So all the best kids. We'll meet you in next session, and if you liked it, do let me know in the comment section how much you liked it, because your liking means a lot for me. Right kids? That holds a hell lot of weightage and energy level that keeps your teacher motivated. Just like me, I keep you motivated. Your comments keeps me motivated, and whatever you want from my side, whatever the help you want from my side, my team side, you just let me know. We will consider each and everything, and I will let you know all the answers of those questions, queries. Bye kids. Bye. Bye kids. I will provide the PDF in your Telegram channel, right? All the best kids. All the best. Jai Hind. Vande Mataram.